Now, I've got a sticky on my original that says, break this booklet into 2 booklets. And that sticky's been on there for about 2 years now. Because I haven't had a chance to break it into 2 booklets. But it'll be okay, I know how to do it in 1 test. So, we will do the front page, then we'll go to the exercise, and then we'll kind of go back. It probably is doable all in 1 day, but the last couple of years have gone better by doing it sort of over 2. So I think we're going to do that. Plus, I know that you might have a few things you need to clean up from that lab too, so that'll actually work out just fine. So when I say after this, you'll be able to calculate average acceleration, displacement, average velocity, instantaneous velocity, and instantaneous acceleration, I'm lying because I think all we're looking at today is this one here. Oh, and maybe that one. Okay? So now remember, I've introduced you to velocity time graphs. We've drawn them, we've talked about them, we haven't really done a whole lot of math on them, and so that's sort of today's topic. So the number one thing you need to do on this upcoming test is identify, is it a displacement time graph, or a position time graph, or is it a velocity time graph, because the rules are different. Okay, so always look to see what kind of graph am I looking at. So this one clearly says velocity versus time. Over here we got velocity, here I got time. This is a velocity time graph. It shows how fast this object is going. Remember there was this one question a few days back where the graph was like that, and I asked you if it was going backwards. Remember that? Right? And that was a good sort of lead into this kind of stuff because the velocity was always positive. So just keep that in mind that we're talking about the velocity. Okay, so average acceleration is calculated the same way that average velocity is calculated on a position time graph. That is by using the slope formula. So all that's new here, you're still finding slope. I know some of you still need some practice on that. We're still finding slope. It's just that you're finding a different quantity. You might remember me a little bit yesterday talking about calculus. You've got a position time graph, right? And the derivative of that is the velocity time graph, and the derivative of that is the acceleration time graph. And does anyone remember what the derivative of the acceleration time graph is? Come on. Starts with a J. It'd be a jerk time graph. That sounds weird, eh? Yeah, jerk time. So when we go this way, we're taking derivatives. When we're going this way, we're taking integrals. There's a little bit of calculus foreshadowing for you. This way, derivatives. This way, integrals. Want to hear a personal story? So when I went to Mexico for my exchange, I'd already graduated, done grade 12 math. The math down there was a regular grade 12 math that I took, and then there was a calculus that I took. And I did okay, and I didn't even know it was Spanish. So then I thought when I was going to university, I'm going to take, instead of regular calculus, I'm going to take honors calculus, because I had already done some calculus. Bad idea. Bad idea. So keep that in mind. Okay. So anyways, we're finding the slope. So given this velocity time graph here, if I ask you to find the acceleration for interval A, that would be this one right here. How would you do that? How about we do this first one together? How would we find the acceleration during interval A? So it would be the slope of this line right here. So this point here is at 2, 4. This point here is at 0, 0, right? So it would be 4 minus 0, change in y's, 4 minus 0, all over 2 minus 0, which would be 4 over 2, or 2 what? Meters per second squared. Maybe today will be the day that everyone gets it right. We'll see. The question is, find the average acceleration for interval A. Find the average acceleration for interval A, the highlighted one right here. Well, does it?
Yeah.
Okay. Well, then you'll get the first one right, won't you? Jason says it gives you all the questions, so you can probably go ahead and find the average acceleration for interval B, and C, and D, and E, and F. And is there a 7? Oh, there is a 7. Oh, there's an 8. Oh my goodness, you got to go all the way to 11. Okay, I'll leave it at 11, and you tell me when you're done, or I'll see from here. When you get to number 7, your possible answers are interval A, B, C, D, E, F, or G is never. And more than one answer is possible. So this is interval A, B, C, D, E, and F. Okay? All right, well, let's have a look at these and see what we can learn from our mistakes. So question number 1 I did for you. And still one person got it wrong. The answer is right there. It's 2. Finding the slope. It's 2. Okay, what about here? What's the slope here? 0. Yay, everyone got it. That would be the average acceleration, right? 0 meters per second squared. The average acceleration. Here, the slope is? It's negative, right? Negative 2? I had lots of answers, apparently. That's quite weird. Maybe I need to do this one. Negative 2. This point here is at 5, 4. This one here is at 7, 0. So it would be 0 minus 4, the change in y's, right? 0 minus 4. It's a 4 divided by 7 minus 5. So that's minus 4 over 2, minus 2 meters per second squared. You're finding slope. And you're going to do it many, many, many more times. Hey, is that the same slope? Looks like a straight line to me. What's the slope? Minus 2. It's the same slope. Right? This point right here is at 8.5, minus 3. This one here is at 7, 0. So it's going to be minus 3 subtract 0 all over 8.5 minus 7, or minus 3 over 1.5, or what do you know? Minus 2. Right? Minus 2. Hey, what's the next one? 0. Yay, everyone got it. We're getting somewhere. We're making progress. What's the slope here? The slope is 1. This point here is 11, minus 3. This point here is 14, 0. So it's going to be 0 minus a minus 3 all over 14 minus 11, which is 3 over 3, or 1 meter per second squared. Okay, more or less people did okay with the slopes, but the interpretation of it is probably where things went off the rails. When is this object stopped? The correct answer is G, never. Question, Jason?
Isn't like when the y crosses 0,
it is. That is true, but that you don't have an interval that is a possible answer there, right? So Jason is saying that actually at 3 spots, right there, and right there, the velocity is momentarily or instantly 0, right? So the question says, what intervals does it stop? So G never is your best answer. Does that make sense? Now that you see it? Yes? Okay. If you want to go back and change some answers here. When is this object moving backwards? It's moving backwards when the velocity is negative, which is intervals D, E, and F. Right? These ones right here. D, E, and F. The velocity is always below 0. Vinny, you need to put the phone away and listen. Please, I'm begging you. Okay, it's negative when it's down below, D, E, and F. When is it slowing down? Now, this is the hardest question there is. Objects slow down when their velocities approach 0. So when are their velocities approaching 0? C, and F. Those two right there, because it's getting closer to 0. Does that make sense? Moving towards 0. Hopefully none of your overall marks are moving towards 0. Light-hearted attempt at humor. Didn't go so well. What is the object speeding up? When the speed is moving away from 0. And the answers are A and D. At 11, when is it moving at a constant speed? Anna, you were asking about this one. When is it moving at a constant speed? That's when the velocity doesn't change. So that would be there and there. Intervals B and E. Okay? So check those things, put stars beside them. Make sure you learn from your mistakes. We're going to deal with displacement on Monday. Okay? Displacement can be fairly challenging, so we're going to leave that for Monday. Here's what I want you to do. You can. I would like you to do, there's how many graphs at the back there? 4? Okay, so on all 4, you can do all the acceleration ones now. Okay, I'm not saying you have to, I'm saying you can. So you should be able to do on graph 1, A to F. Graph 2, you can do A to... Actually, no. You can only do average. A to C. This one here. Number 1. This one here. Any of the A bar ones. You could try those ones. Whoops.
So A, C, and D.
Yeah, A, C, and D. You could try B, I guess, if you want. Okay? So all of the average acceleration ones. If you need time to finish up that lab from yesterday, let's do that. I need to create a Schoology spot for you to submit. You probably need to submit so you grab a laptop. Let's do that. We'll do displacement on Monday, and then we'll get ourselves started ready for the test.